Hello, welcome to the AI Digest podcast. My name is Joaquin Milata, and I'm your host. And yeah, today we're going to be talking about a particularly interesting technical concept that I've been wrestling with the last 2 years. From not knowing anything to talking to a lot of interesting guests. A peek behind the curtain. So, how can large language models, ontologies, and knowledge graphs work together? This is also, being referred to as graph rag, but we're going to pull on some strings that are going to make the picture a little clearer. And with us today is Dr. Bilal Ben Maria, and he's going to tell us a little bit about who he is, what he does, and what his interest is in the topic. So, Bilal, pleasure to have you.
Thank you, Joaquin, for having me today. In fact, Bilal Maria is a lead ontologist and a doctor, lead ontologist at Clevadis and at the same time a doctor. Passionate about connecting AI with structured knowledge. I worked on building ontologies, knowledge graphs, and also creating systems that are relying on the LLMs in order to help organizations reason better with their data. In fact, enjoying turning complex problems into practical ideas. And also sometimes I can teach and speak about how AI knowledge graphs and LLMs can work together in order to build smart solutions.
And I appreciate you, Bilal, because in a previous presentation you've delivered, you disambiguated this term knowledge graph. There are two major camps that go along that, and then there are some other fakers, and we're going to get into that. But I appreciate you for that, for your deep thought, and also maybe just a little bit more background. You could tell us a little bit about some of the applications of knowledge graphs that you've worked on, and your
No.
fascination with knowledge.
Okay, good. In fact, this is good, and I appreciate this question. In fact, Joaquin, because in fact we need to clear up the terminology. This is the first thing that we need to do. So, because currently in the literature we can find people that use, for example, ontology as an alternative word with a knowledge graph. People can use property graphs as also a synonym of knowledge graphs, and this is in fact not good. So here, I prefer always to rely to define an ontology. In fact, I prefer to rely on Tom Gruber definition. Okay, why? Because Tom he said that an ontology is a formal, explicit specification of shared conceptualization. He gave, in fact, let me tell you that we can write a book about this definition. Okay, because I'm not exaggerating because
No, I
it
agree.
it because it gives us five components that we can rely on to define an ontology. The first one, it's a formal, which means it should rely on the logic and it should be machine readable. Explicit, which means we need to define all entities and all relationships without any ambiguity. A specification, it means that we need a set of rules and vocabularies that can cover this concept, these entities and the relationships. And the key is the shared conceptualization. The shared there, it means that we need the consensus, about seeing or creating an ontology, consensus about choosing the concept, the entities, the relationships, and then finally we have the conceptualization, because it is an abstract model, and where we can represent ideas, and also its concrete model, and so on. So if we can combine these five components, we can quickly find the difference between property graphs and ontologies. So we can answer this question by asking other questions. Answering this question by asking other questions. For example, does the property graph is formal? No. Does the property graph, for example, contain the concept of explicitity? No. Specification? No. Shared conceptualization? No. So the property graph is a synonym of the text graph. Just nodes and the relationships. And then we have the knowledge graphs. Here, I can say something. The knowledge graph can rely on the ontologies as a contract, as a schema that the knowledge graph can respect in order to populate and to create the data. So it's like, for example, the knowledge graph, it's data plus the ontology. It's not just because we need schema and the contract, and then we need to populate or to respect this contract in order to fill in the data. And some people also can see the knowledge graph can rely on the property graphs. I personally see that this is not knowledge graph, it's just text graph. Okay, so because the term knowledge, it's very deep term. Okay, and in fact, if we are back to the philosophy to define what is knowledge, it's very hard to say that the property graph can represent knowledge, but the property graph can represent the data in a graph way.
I really appreciate you giving that 5 point definition on what an ontology is. Um, it is such a slippery thing to materialize and grab onto as a functional tool. You know, I have taken like intro to contracts and legal frameworks and stuff like that in community college, and everything's a contract, right? Every interaction we have, a verbal agreement that we have is a social contract. It's not enforceable. A written contract between two or more parties is we have consideration for each other and terms and conditions that must be fulfilled in order to exchange the goods that have been agreed upon. But then when you bring computers into it, now there's a layer of interoperability between systems, machines, and people, and that's a much harder thing to kind of convey to people who are not technically proficient or maybe don't have as much background knowledge as to what this is. But I think what you've described also is a social phenomenon. Where are you based out of? Morocco, right?
Morocco, yes, Morocco.
And I'm in New Jersey. So we have an agreement in some terminology, and because we have agreements in some terminology, we have alignment and we can
Yeah,
contract with each other.
yeah.
If we do not have alignment in terminology, we cannot contract with each other.
Let me tell you an example, Joaquin. So for example, I can speak now English language. I can use, for example, I woke up at 9 a.m. Okay, and I eat something. I add something. Okay, now I can if I am free. Okay, and I can, for example, invert. I can use, for example, instead of saying eat at am, I can say woke up at am. But in my intention, I want to say eat. So what is the consensus that can, for example, people use, okay, in order to see, oh, Bilal want to see, for example, eat and not sleep, because of the vocabulary. Because we have a vocabulary that can be used as a unified framework. Okay, but without the vocabularies, I can talk English, but different English than you talk.
Moroccans are amazing people. I had two Moroccan friends in high school, and they would fluidly interchange between Arabic, Spanish, French, and then whatever other mixture of those two. I speak Spanish, so
Yeah.
si hablamos español, uh, we could still
Okay.
kind of communicate at some level. But if you start speaking French or you start speaking Arabic, I can no longer contract with you because we don't have a shared vocabulary, a shared schema of language,
Exactly.
of a representation of the world.
Exactly. Exactly. This is the main point. Yeah.
So with that, you're talking about consensus. You have
Yeah.
to have a consensus between a group of people.
Yeah.
Now, under normal circumstances, we colloquially refer to an organization as like a company, right? Like usually they're for profit or non-profit or whatever, but they have multiple functions that create value that blend together to fulfill the mission of whatever organization they have. They have a marketing department that makes promises and tries to communicate to the customers that they serve that they can do a value add, they can solve problems for them, and when they come, then there's sales. Sales has a dialogue to convert them into cash, and then
yeah,
once the sale and the contract is executed,
yeah,
someone needs to fulfill the promise, and then that cash is faithfully earned, right? But each of these three areas has a different view of the world, and they share similar vocabulary,
yeah,
and they think they have the same definition for the vocabulary,
yeah,
but in fact it is slightly askew, right, based on their lived experiences and what kind of functional tasks they serve
yeah.
in an organization.
Yeah, and I like, in fact, I like the word agreement, Juan. Yeah, because if we want to define, for example, the ontology in the industry, we can see, for example, it's a formal agreement about how we can see the global. So the ontologies, for example, can help us to understand how and what and how, okay, what exists in this global, and how we can represent these things, okay. But on the other hand, as I said, if it could be that I'm wrong, but this is in fact my point of view. If you if you see the property graphs, it's like data structure implementation. I don't know, but it's like a data structure implementation. Okay, but also property graphs can solve a lot of problems. In fact, okay, and but the difference here is that the property graph is a proposal engineering. It's an engineering proposal. The ontology, it's not, it's a philosophical proposal, okay, that combines a lot of things: engineering, linguistic people,
Well, it's a
yeah,
legal it's a legal contract, no? I mean, it's
yeah,
it's a computable contract, really, like it's
exactly, yeah,
schema, right? Shared
yeah,
representation of the world, of entities, of relationships, of considerated parties, whatever.
yeah. Exactly. So people are used. So in our daily basis, people are using, in fact, ontology in their communication without knowing that. Without knowing that. Okay. Okay. So if you go to the inside our brain, it's just non connected. Okay, connects neurons. Okay, and in order to describe something to someone, you need to start with features and then connect these features with other features and then with other features in order to give him or her an idea about what you want to see.
There's a famous essay on communication by one of the earlier management consultants. His name is Peter Drucker, and he talks about this idea that communication originates in the listener, in the one that receives the message, because we can talk about things, but in our brains, individual brains, we have schemas that represent the world, as you said,
Exactly.
vocabulary, lived
Exactly.
experiences, associations to things. And if I say something that does not conform to your schema, that is not validated or verified or can't be ingested,
Yeah.
then whatever I say is going to be nonsense to you. Likewise, if you
Exactly.
say something to me in a different language or whatever,
Yeah.
same phenomenon occurs.
Yeah. Exactly. Exactly. Yeah.
So then, how do you all right, I feel like we need to just put our feet on the ground one more time. So we're talking ontologies first. You defined it beautifully. Now
Yeah.
we're talking knowledge graphs. We've disambiguated that knowledge graphs is a term that is abused and distorted and mutated according to marketers or
Exactly.
engineers that have been misinformed,
Yeah.
or maybe people that want to buy into the hype and trend of the rising popularity of knowledge graphs. I've seen conflations of vector databases, of label property graphs, and semantic knowledge graphs that are using ontologies that are backed by W3C standards.
Yeah.
So maybe we can disambiguate. Maybe you could tell me a little bit about the hybrid, about the vector databases, and then we can take it from there.
Okay. Good. So it's the name itself can describe what is vector databases. Okay, it's like we have a text. Okay, and then we need to convert this text into a numerical representation that we can call in the literature embeddings. Okay, and then in order to benefit, okay, because the normal databases, okay, are not, okay, sufficient or ready enough to support, for example, the representation of these embeddings, and also to do some calculations on these embeddings and indexations and on these numerical representations. So the role of the vector databases is taking this embedding, put it simply, taking this embedding and store them in a vector database in order to benefit from them in the other staging for building system. So this is just the first stage. Okay, it's like creating embedding, store the embedding in order to or use this embedding in other stages. So, and this is the role, in fact, of vector databases can help us in order to accelerate calculation, the performance, extracting. We can see that also in the vector database we can apply code operations, but in another way. Okay, create, update, delete. Okay, we can do that, but in another way. Same operations, but now we can apply mathematics, we can apply other kind of operations in order to benefit from this numerical representation. Yeah.
When I hear vector, I hear physics. I hear magnitudes and directions and clusters of things. It's a matrix, right? It's a
Exactly.
representation of how these chunks of information are being kind of stored. Like if we had rows of bookcases and you had chunks of embeddings, you would arrange the books as the chunks into whatever proximity things start to cluster together, right?
Yes, exactly.
So we've defined ontology. You did a fabulous job. You've disambiguated and disentangled and wrestled the knowledge graph word, and now we're talking about vector databases. Let's talk about large language models. That's a really big deal. Everybody thinks it's going to save them and their grandma, you know. So maybe you could tell me a little bit about large language models and what they represent, maybe some of their limitations, you know.
Yeah. So in effect, large language models, or the LLMs, the first goal from of them is to solve the problem of the next word prediction. Okay. So, for example, if we have the revolution, is started with the paper that is called "The Attention Is All You Need." Okay, but in fact, I didn't remember now the name of the paper, but there is another paper before this paper that mentioned the attention. I didn't remember the name of the paper, but there is another paper. Okay, so the LLM, it's just a deep neural network architecture with a huge number of parameters. And when we see a huge number of parameters, so we are talking about billions of parameters, depends to the model. Okay, so for example, for the GPT-2, for example, we used to have 124 and the other variations. So to put it simply, the LLMs are just deep neural network architectures that can rely on a huge number of parameters. We can call big, as we have big data, we can see big parameters are the billion of parameters. And its goal, it was that solve the problem of the next word prediction. So if, for example, I typed something like I am Bilal bin Maria, so the LLM can help me to invent something in order to define, for example, myself. Okay, this was the beginning, but after that there is something called the emergent behavior. What does that mean, the emergent behavior? Because when people try to solve the next word prediction problem, they found that the LLMs are very, very good also in question answering systems. They are very good also in a language translation. They are very good in other applications that, in fact, the LLM are not trained to do these applications. So, and this is what people in the literature call the emergent behavior, something that we can't explain or justify.
Unexpected kind of emergence.
Yeah, unexpected. Yeah, but we don't need to forget that. In fact, the LLM, in order to give output, it relies on statistical pattern and probability distributions. Okay, which means When I start to give a huge amount of text to my LLM to train it for a task, okay, for example, Wikipedia, Wikidata, books, and a lot of things, okay, there is no control how I can, okay, make this LLM, okay, give me a relevant result without hallucination. So the rate of hallucination, okay, increases, which means that and this is one of the drawback of the LLMs, that they hallucinate. Okay, this is the first thing, and also the lack of transparency and interpretability. So, for example, the alien can give you an answer, of course, okay, but in order to justify this answer, and specifically in the fields like, for example, the law, and for example, the medical fields, these two, and also the finance, these fields, the process of justification is something very, very important, and we can't rely only on statistical pattern in order to take a decision. So here I can sum up. We have the problem of hallucination. We have the lack of the transparency and interpretability. And I want to add something here: the problem of the data controlling. We can't control the data, just give the data. So if I didn't if I can't filter the data or control the data, it means that I can also filter or control the process of generating a result, which means we can hallucinate.
So, wonderful. You are a scientist through and through, very learned man. Um, I want to just peel one more layer off of this onion. What are neural networks? How would you describe those?
Here,
This
the,
might be
the, the,
too broad.
the good person to describe that is Geoffrey Hinton, the godfather,
What? Oh,
Geoffrey Hinton, the godfather of AI. But in fact, the neural network, it's like a set of neurons. Okay, if you can imagine the brain.
like
Okay,
in the brain, we have
yeah,
neurons,
yeah,
right?
yeah.
And
Set
they have
of set of neurons. Okay, that are connected. Okay, and this neuron can, for example, accept some input. The input can be, for example, the image, can be the text, could be the video, uh, all kind of information we can pass to this neural network. So the role of this neural network, or the definition of this neural network, is use its parameters, okay, in order to learn, okay, from these data, in order to give us an output. It's like set of neurons that are connected with each other in order to give us a result. But how we reach out this result, no one can justify that.
there's I've looked at like neurons and synapses in the brain, and I've
Yeah,
tried to understand the similarities because obviously we are attributing neural networks to the neuron function and a network of them. So people are trying to anthropomorphize the phenomenon of computers by looking at how biology works. But I understand that a neuron is one node, and then a synapse is the pairing, or is it backwards?
exactly.
Wait,
And let me add something here, Joaquin, because the neural network, it doesn't mean the functionalities of the neural network, of how the neural network functions. It doesn't mean this is how our brain is functioning.
no. They're pretending. They're
Yeah,
mirroring a
exactly.
similar functionality, and they're
Similar
calling it.
functionalities.
It's an
Exactly.
easy thing to describe what's actually happening.
Yeah.
But in the synapse, there's a threshold that accepts a certain signals based on something going on biologically. I'm not qualified to talk about that with confidence, but that's the same kind of function, right? There's a threshold that must be crossed for the neurons to accept an input to go, and as you keep feeding it things, it starts to detect some patterns.
Well said. Yeah.
How does that work? And I'll stop bothering you with deeper questions around that. I just
No, let me. I will ask you. I will answer honestly. Okay, I will say. I will tell you that I'm not qualified enough. Okay, to go deeper. Okay, and explain these things deeply. I can explain them, for example, technically, but go deeper.
right.
Yeah,
You,
yeah. Go deeper and, for example, explain these things using biology or these things. I can't do that, to be honest. But I will share here just my vision, okay, about the neural networks. I always, okay, imagine the neural networks like, for example, a graph, okay, and this graph, for example, has its features, but the difference between us and the neural network, okay, our network and the neural network, okay, the artificial neural network, is that as a human we have a knowledge about our features, but the neural network, it doesn't have any knowledge about the features that can accept as input in order to take the decision.
yeah, there's
Okay.
no. It's a blank slate. It's a
Yeah,
blank. It's a white
exactly,
paper.
exactly, exactly. So yeah, so this is in fact the small, okay, definition. And technically speaking, we can start with the it composed of input layer, the hidden layer, okay, and the output. And in the hidden layer, okay, there is in fact no this is one of the challenges in fact to the
No
best
traceability. There's no
no choice.
transparency.
And also we can't control the number of hidden layers, okay, because it's very hard to find like an algorithm or solution that can tell you. So for this problem you can, for example, use 5 hidden layers, or for this problem you can use 10 hidden layers or something. You need to experiment, and this is in fact one of the things that can make the process of finding the good architecture of a neural network very, very hard.
Fascinating. I really would like to dive deeper into this, but I'm not gonna extract more. Where let's go back to where we have the discussion and your expertise, and let's keep the conversation fruitful. So you mentioned some of the limitations of LLMs, and you were going to talk about the limitations and probabilistic systems when you require precision and knowledge that has lineage, and that you can rely upon with the same accuracy of an expert, right? Expert systems that have deterministic rules. So can we just disambiguate a little bit of the limitations, like you were
Mhm,
saying?
mhm. So, in effect, based on my understanding, okay, there are 3 waves of the AI. Okay, the first wave is what people can call the good old-fashioned AI. Okay, and in the good old-fashioned AI, the approach relied only on explicit rules, okay, logic, just explicit logic. It's like imagined situation, like if-else statement, okay. This is the first wave, okay, if it's correct to call it AI or no. And then the second wave of AI, it started with in fact neural networks and deep learning. And here I want to mention something. The deep learning and the neural networks uh, has appeared, okay, a long time ago. Okay, just the problem that we had, we don't have super machines that can compute this huge amount and formula of mathematics. Like, for example, this matrix multiplications and these things. At that moment, okay, we don't have, or we didn't have, in fact, the super machines that can invent, okay, or calculate, okay, this mathematical aspect. So the second wave is with a deep neural network, and it relies on statistical learning for massive data. Okay, just and here the problem with this wave or this approach, as we mentioned, it's the hallucination. This is the first thing. And what does that mean, hallucination? It means that the model sometimes can give you wrong answers. Okay, and for me, it's this is not the risk. The risk is that when it gives you a wrong answer, and you don't know that this is a wrong answer. And this is one of the things that we can observe people doing these days. They are talking about concept just by chatting with for example AI, and then they start to tell us a lot of things that are wrong. Okay, and this is the risk. Okay, so if there is a hallucination, we need to find frameworks or things that can help us in order to catch these hallucinations. Because let me share with you something, Joaquin. I was thinking to build a small LLM, okay, and as an input, I will train this LLM only on wrong information, pieces of information. And then I will say, okay, I have this small, but I will train it only on. So if you are not an expert or something, you will kill, okay, yourself and people with you, because the wrong knowledge can kill and destroy communities. Okay.
Well, I think you know, yes, you're bringing up a great point. This is a probabilistic machine that absorbs a inordinate amount of text, and it assumes patterns, and based
Yeah.
on patterns it regurgitates patterns that are likely to be truthful and sound right, but they are not in fact right, and they may in fact say your kidneys in your ear and your liver's on your elbow, and should I consume poison? Yes, it's good. Oh, the poison hurt me. Yes, poison is bad. Like there's no threshold for saying yes or no. It just
Yeah.
treats you and gives you answers that sound
Exactly.
plausible without a confidence score or a citation lineage of true resources. Um, you know, Sorry, go ahead.
Yeah.
I,
So
I kind of
so
lost.
generally speaking, the problem of hallucination, it's not just it hallucinate, but also it impact on how we are building our communities, because these days people are using this source of information in
Yes,
order to become,
yes.
in order to become experts or something in the field.
I was going
Yeah.
to give an example that I came across through another event that I ran, and it was in the clinical sense. There's a person that they were developing a clinician assistant for taking notes and kind of like helping act as like a second brain for physicians to be able to do more work and do it more efficiently. So they noticed that when they approached young doctors, people who just got out of med school, they were over reliant on the machinery because they assumed the machinery was a sign of authority and that it was able to compensate for the lack of experience.
Mhm.
When it was brought in front of
Wow.
experienced doctors, they looked at it like a toy and they broke it. They found every way to manipulate the machine to see how how bad could it be based on their deep knowledge and their deep expertise.
Yeah.
So that's dangerous, of course, if you
Yeah.
don't have a
Yeah.
label on it, you know,
Of course.
like with cigarettes,
Yeah,
everything should have a
exactly,
label.
exactly. Because in fact, I don't like to see these things. Let me give you an example, specifically in the area of software engineering. I know that recently, for example, the CEO of GitHub mentioned something. I was watching a podcast and he said, right now we can, for example, dream about an idea Saturday at night, and then we can implement it. Okay, on Monday, and boom, we can, okay, take feedbacks from customers. I totally agree with this, but the point is that these tools are used by genius programmers. They don't have any background knowledge about if you are an expert, okay, you can manage, you can get by. But for the genius, okay, the programming is not about typing code or something. The programming is a way of thinking. The algorithm is a way of thinking. So if our junior programmers start to use the code, the code that is generated by AI in their earlier ages, okay, so at that time exactly we are destroying these junior programmers by killing two main important skills that are problem solving and critical thinking. Okay, and in fact, I don't like. I hope that there are regulations to stop or to prevent juniors from using the AI tools until specific age.
They've already found bridges collapsing, lawyers fabricating reports, major consulting firms like Deloitte using AI to generate reports worth millions of dollars for government agencies. They've done they've shown doctors giving bad advice because they use ChatGPT as an augmentation, but it's a transference of liability to use this as a an extension of your practice if people are coming to you for expert counsel, legal, financial, medical, and there are serious repercussions. The person that delivers that expertise
Yeah,
is liable for that. Um, yeah, yeah. You bring up a good point. The abstraction of problem solving is preventing these students from training their neural networks.
yeah,
Right?
exactly,
They're not
exactly,
building the
exactly.
capacity and resilience and pattern recognition and how to work through those difficult to solve
Yeah,
problems.
yeah.
Right?
In fact, there is a term that I always use during the meetings. It's the term transfer learning. Okay, when someone from my team, I want him to transfer his learning to another member. Okay, why I'm seeing this example? Because now our students are doing the transfer learning from the AI, not from human to human, but a human to machine to human. Okay, so here there is something very dangerous. In human to human, there is a process of exchanging, but
Right. The
in
feedback.
machine to human, there is no
Yeah.
exchange. Okay, so you are just consuming without producing, and this is another. Yeah,
There's a book that I love that's from like the early. I don't even know what year it's from, but it's so good. It's called Thinking with a Pencil, and the book talks about the benefit of not just developing graphs or charts or things like that. First, it's the acquisition of the facts, the arranging of the facts, and then evaluating the utility of that. If you come across new data points, how can you better arrange this visual representation of knowledge?
yeah,
Because it's about the knowledge and experience and frameworks of viewing the world is the byproduct of doing the work. You
yeah,
cannot abstract
exactly.
that, you know?
I agree. I agree. Yeah.
So I love the conversation. I love that we're talking about learning. Let's move back on to the topic of tracing the string from now we have these LLMs and people engage with it as inputs and outputs. Like you said, it's a black box and it's composed of the likelihood of all the trained material, all the corpus that's been fed into it. It's been blended together, and
Yeah,
now there's like bookcases filled with words and chunks and things. But it's probabilistic. And then we talked about ontologies being social contracts, social technical contracts that specify entities, relationships between entities, vocabularies, the multitude of disambiguation between vocabularies, because one word can mean many different things to many different
exactly,
groups
exactly,
in many different languages too.
exactly.
And then we talked about the disambiguation of knowledge graph, the terminology. So let's talk about how do we jam these things together. Ontology is wrapped. A knowledge graph has the heart, the beating heart of an ontology, and now we have LLMs that are probabilistic. So we have deterministic, probabilistic. How do we make them merge?
Okay.
How do we get them to work off each other?
Okay, good. This is good question, and in fact, we can answer this question by
Oh,
yeah.
sorry. One last thing I want to just throw in the pot so that you can jump off. Knowledge graph is the instantiation of an ontology with data. We missed that part.
Data plus, yeah, plus schema. That is an ontology.
I just
Yeah.
wanted to put that out there because we didn't cover that
Oh,
before.
okay. So, in effect, I want to add something before jumping to your question. Okay. It's another drawback, for example, because the LLMs, they can't reason reliably on fact. Okay, and their knowledge is frozen in time of from training. Okay, data, and they lack the connection to source of truth. Okay, so this is one of the main drawbacks. Now, to answer the question, how we can combine all this system, let us call it system. Okay, we need to ask another sub questions. The first sub question is that how do we ground these models? Okay, this is where, for example, two concepts from AI and data science make powerful comeback. So the ontology plus Kiji, and think we and here we need to think about ontology, okay, as a book of rules, okay, as a book of rules that contains specific, okay, and as I said, a set of rules that are defined formally, okay, and help us in order to understand the relationship between the entities in our global. Okay, now the question that we can ask ourselves is that how does an ontology help an LLM? And also because we don't need to deprioritize LLMs or underestimate LLMs, to be honest, okay? Because also the LLMs can help us in order to do a lot of things to build knowledge graphs. And here, Joaquin, I want you to give me time to explain something that people are claiming currently, okay? But let me first start. How does an ontology help LLM? By put it simply, by providing rules. Okay, so tells the LLM what concept and what concept are valid and what concept are not valid. Okay, so instead of saying, for example, give me for example, give me the salary, or give me a list of product, for example, just seeing that, give me a list of product, okay, based on the rules that we are injected in the ontology. And here I will take, for example, fiber ontology. I can, for example, reformulate, okay, my question to make it more complex. Give me, for example, the list of all products that are relevant to a specific domain. Yeah, please go ahead.
When you say FIBO, you mean a finance ontology.
Yeah, exactly.
Let's disambiguate the domain.
Yeah, it's the finance ontology. And here I want to, in fact, to say thank you to people that are working on this ontology, because in fact it's super standardization, okay, that we are using, and specifically if you are working on finance field. Yeah, so here put it simply, as I said, the ontology just provide the rules, okay, to the LLM, okay, and tell to the LLM, this is the rules, okay, that you need to respect in order, for example, to give knowledge. But in order to do that, the question that we need to ask is how we can train LLMs to understand ontologies. Okay, this is the main question. Here, I want to open another question. In fact, working people that claim the LLM can build an ontology. Okay, and this is wrong, and I can tell you why. And this is from my point of view.
Wait. Say that one more time.
The LLM can build an ontology.
And you're saying that's wrong.
Yeah.
Let's
partially wrong. I will explain
thank you,
partially wrong. Yeah, partially
thank you.
wrong, of course.
Yeah, let's approach with a degree of care, because
Exactly.
things could be true and untrue.
Partially, because, and this is also my point of view, to be honest, because I can see people that can contradict or against.
There are purists. There are people that say LLMs are going to overtake ontologies. Yeah. Goodbye, ontologists. And then there are ontologists that say never.
I'm always asking people one question: if the LLM can build an ontology, apply the definition of Grover on the generated ontology and let me know. Okay, the first thing, it's a formal. Okay, does the LLMs can understand the logic? Okay, the complex mathematics. let me tell you why people say LLM can build ontologies. I can tell you why. Because they are thinking ontology is a set of concepts and relationships. But what about the constraint? Okay. What about the axioms? Okay. And what other lot of things? Okay.
Yeah, they
So
just think it's a representation of words. It's word
exactly.
salad. But
Here I want to say that the LLMs can be the author, but the ontologist must be the editor. And the process, yeah, please go ahead, Joaquin.
no, I was just gonna say I had a conversation recently with Jason Kaufman.
Yeah,
He has been a knowledge manager for 30 years, and he discussed the utility of LLMs, but for managing large amounts of text. But ultimately, he shared with me a concept called verifiable knowledge. So whatever chunk of information is being processed, as long as it has the stamp of approval from a human, as you're saying, the human is the editor, the final say, right? If something is wrong, they can rectify and attribute it and tie
yeah.
it to everything else. So that's verification, right?
But this is the complex process. The complexity. It's not in the creation. The complexity it is in the evaluation. Yeah. So and here I want to mention another thing. Okay, just we need to be aware of what is an ontology and what's a property graph. Okay, if we talk about an ontology, we are talking about something that is very big and complex. I can people that can go with the opinion of LLMs can build an ontology based on my experience in the industry. Okay, it's small experience in fact. People are using property graph as a synonym of ontology. Okay, so this, and in order to explain to them what is an ontology, they quickly start to tell you, oh, it's very complex, I need just property graph. But you see that your ontology is created by the LLM, and you give me this ontology to evaluate it, and now I'm telling you that this is not an ontology, it's just a property graph. Oh, okay, I want this property graph. So the conclusion what? In the companies, not all the companies, of course, they use something that they can use. Okay, just if it works, it works. It is an ontology or it is property graph, it doesn't matter. Okay, and this is why I want to say here the ontologies are appeared in the laboratory of research and or in the research laboratories. Okay, and when they migrated to the industry, okay, the industry, in fact, not all, of course, just based on my small experience, they changed the identity of the ontology.
Um, yeah, semantic knowledge graphs powered by ontologies that are using W3C standards, they're great.
Yeah,
They're
yeah,
great because they allow you to define terminology, tie it to linked open data that's globally recognized. So,
yeah,
there's an international resource that has been defined, and that you can interoperate and you build your colloquial terminology for. If I want to speak my knowledge graph in Spanish or in Arabic or whatever, cool. Now we have the technology that allows us to work in a global contractual context, and we can agree and negotiate with the things that exist and have been coined and disambiguated on our behalf. We just have to work with the things that have been given to us, and then label property graphs at a very tactical level, like you said, a text graph. You could take a spreadsheet. I could dump my relational database query now and visualize it, and I can call it a graph. Yes, indeed, it is a graph, and I could do useful operations with it. Yes, indeed, I could do graph data science. In the local context of that thing, and I can deliver value, and I can secure sponsorship, and I can train people. However, I do not take advantage of the technology and work of other people. I do not have the capabilities of letting the machine do inferencing So follow the logical thread of defining what is a concept, what is a child of that concept, what
yeah,
kind of inheritance of properties does it take, so the pure way, someone like you, a doctor, will pursue the true benefit of realizing the utility of these technologies.
mm. And in
But
fact, I'm still learning. Okay, a
no,
doctor, a
no,
doctor,
no.
a doctor.
It,
It doesn't mean. Yeah,
this is called the practice for a
yeah,
reason. Doctors graduate from medical
yeah,
school and they have
yeah.
a business called the
Okay,
practice
yeah,
because they're not perfect, right?
yeah,
Even doctors are
exactly.
making mistakes every day.
Yeah,
So, and they go to school for 16 years and they're still making mistakes,
yeah, yeah. I
Um,
agree.
but I want to say I understand the people want to go the easy path because
Exactly.
the time to value is incredibly fast.
But let me tell you something, Florian. They started to go the easy path, and I will mention here just one problem. It's the data integration. With the property graph, if you want to do the data integration, it's in fact an engineering hard work. You need to
It's
code.
nearly impossible.
Yeah, you need to code everything from scratch. Okay, but if you have an ontology behind scene, you can achieve that quickly. And just it's an ontological problem. Just an ontologist can solve the problem of data integration if this data it's relied on an ontology in its representation.
You're describing a really interesting, and I didn't make that connection before. When you work with label property graphs, you're just changing the format from relational to a fake kind of graph, kind of,
Yeah,
it's not fake, it's not a fake graph, to a graph. You're taking relational to graph, structure to semi, fluid. You could see some relationships, but when you do the ontology, that is a step above. It's a schema. Now we are with contracts. Now we could look at any database and absorb and connect and transform programmatically, but we have the same representation of reality.
yeah,
So
exactly.
you're
But yeah,
connecting at the low
yeah.
level data to data
Yeah,
data.
yeah, and just I want to mention something here, working just quickly. We can't deny also that the property graphs have big impact on shaping the industry. We can't deny that because they have their benefits. Okay, but just to clarify this, what we are what we are clarifying here is that don't combine or don't use property graph as an alternative word of the ontology or something
Agreed.
like that. Yeah,
100%.
yeah,
100% agreed. So you said, you're using words in an LLM, but they have no meaning. They're just words that happen to come up with a Russian roulette. Like random chance. You roll the dice and the word comes out. But we would like to tie in the emptiness of a word with the precision and the context and the lineage and the international recognized terminology of an ontology and tie it to the data sets that are applicable. So how do we do that? What do you think is the path forward there? I think that's the juice of the whole
yeah.
conversation.
In effect, here we are talking. I will not talk about the graph hack. Okay, here or there or
No,
something.
let's stick with the
Yeah,
technologies and
but
let
uh, but here I want to mention something that is currently is active as a field of research. It's the neurosymbolic AI. And the neurosymbolic AI, I can consider it like a third wave of AI. Okay, why the neurosymbolic? The LLM excel. We can't deny that. Excel in a lot of tasks, like pattern recognition, like summarization, question answering problems, and a lot of things that are relying on the intuition. Okay, the but this is the norm. And the symbolic is that how we can help these LLMs in order to do symbolic reasoning and do the logical reasoning over the data that it can provide to us. How we can integrate these two things. And in fact, what I like about the neurosymbolic, it doesn't choose between the two. It combines the two. Okay, it combines the LLMs and the knowledge graphs, and it aims to build system that, in fact, system that can learn from data. This is the norm, and at the same time reason according to the rules and according to the ontologies. How we can do that? There are in fact a lot of approaches in the literature, and this is in fact something that I am touching currently, Joaquin, which, and here I want to mention that, which pushes me to study the LLMs from scratch and to build LLM from scratch in order to understand the mathematical background that is behind the scene and understand specifically where we can put the ontologies in order to benefit from, why not, knowledge LLM, not just knowledge KLLM, knowledge LLM, something like that, okay? Uh, and and in order, in fact, to answer the question of how, there are a lot of approaches, and as I said, one of the approaches is the neurosymbolic, and this is the active one currently. The neurosymbolic, why? Because it wants to combine the two, use the data for a neural network for the data, and use the ontology in order to reason over that data. And this is the main active, in fact, area currently that people are touching. And I hope that also I can contribute in this. And of course, I'm open to any collaboration, okay, or something. If people that are hearing us right now want to contribute or something, yeah, we can build something strong together.
I could put you in touch with a few people.
Yeah,
I've been
please.
dipping my little toe, my little foot toe into that, but it is way above my knowledge, my existing knowledge. As I have conversations like these, I'm able to better understand and dip another toe, but it's very much an incremental way for me to learn, and I can appreciate, you know, the utility of a deterministic system, a law, right? Like a rule book of law. If this do that, if this do that, if this do that, for whatever threshold, that's so beneficial for building for building a guiding a skeletal structure. That's great. But in the pragmatic, in the absence of context, we need a level of interpretability, right? We need to
Yeah,
be able to
yeah,
walk through the fuzziness. So if something originates from pure deterministic knowledge, and then there's a level of interpretation, and then there's a feedback system to train whether something is positive or negative, so that the system can learn, like, really, not as an organism, but learn with data that reinforces the follow decision, plan, do, check, act, log the performance. I think that is the when we're going to really start to get
yeah,
into really interesting stuff, and that's neurosymbolic.
yeah. And at the same time, I want to add something short. Good idea is not enough. It should be good and practical, taking into our consideration also the cost. Because when I was studying the process, for example, of training, okay, the LLMs on the ontologies, and this is just predictions. I didn't do any experimentations or something. Okay, it's like I felt the cost of the training, it will be high, but it could be I'm wrong, because as I said, it's just a set of predictions. This is why we need to find a way how we can create something good and at the same time practical.
There's Rashid Benuini. Thank you for watching. I don't know if that's a colleague of yours. He's in Morocco.
Yeah, yeah.
He's
Thank you. Yeah, thank you, Rashid.
watching.
He's my
Um,
best friend.
okay. Yeah, man. Is there anything that you'd like to say? As a sign off
Okay,
to
here
your
I want to say, yeah, I want to mention something that is not related to the technology. I want to say to the new student, study mathematics deeply. Okay, why? Because as we can see currently, everything is automated. But in order to understand and contribute, you need to study the kernel of these things. And all the kernel is based on the mathematics. So I think in the next iterations, we will rely on mathematics more than other people. So yeah, this is just also a prediction. Yeah, just prediction, but yeah, it could be wrong or yeah,
No, I agree with you. I
yeah,
mean, you can't escape the hard work, right? And mathematics gives you the rigor to be able to manage through complex problem solving
yeah,
procedures. The purity of math is great, but it gives you the equipment to go and deal with
yeah, exactly.
social dynamics, economical dynamics, technological trade offs, right? Because you're not just building technology in a bubble. You have to pay for the GPUs, you have to pay for the electricity, you have to pay for the talent, you have to develop the trade offs in the roadmap, and everything has to be operationalized. So, hey, Michael, with that, let's sign off. Just stick around, Bilal, and thank you everybody for watching. I hope you had a good time.
Okay, thank you.